Hello, ladies and gentlemen. Today we're going to be taking a look at other types of angles inside circles. And so for this, you're going to need that little chart to kind of organize some formulas on there. We're going to fill some of that in, and you need to be careful to pay close attention today. If you're not going to take a whole lot of other notes, you need to watch these examples because that's going to help you out on some things called circle puzzles in days to come, okay? So something to write with, a calculator, and that little chart would be helpful. So remember where we've been. We've been talking about a central angle. That's an angle that has its vertex at the center of the circle. So this is a picture that you already have in your notes. A central angle located in the center of the circle. That's why it's a central angle. And we know that the measure of angle C is congruent to the measure from A to B in that arc. So the angle in the center equals the arc across from it. So let's go ahead and organize that in this chart. So when the vertex or the pointy part of the angle is located in the center or in the circle, it can be made by two radii, as you see here. This is called the central angle. So I'm just going to draw a little mini picture here. The angle will be located in the center like this. That's where the vertex is. So what is the angle? Well, the angle equals the arc across from it. So the intercepted arc across from it, the angle and the arc are going to have the same number of degrees. Okay, we have not talked about two chords and what that means in terms of the angle in the center, but we're going to come to that in just a little bit. So yesterday our angles were like this little teddy bear sitting in the center, right? But what happens if I pretend that little teddy bear is sitting on rubber bands and I take that angle, that teddy bear, and I start pulling it back like I'm going to launch it like this? See how that angle got smaller? It's the whole rubber band idea. The more I pull it back, pull it back, pull it back, the skinnier that little angle is going to become. So he's not equal to the arc anymore. He got smaller. So here they were the same. The number of degrees here is the same as the number of degrees here. But now that I've pulled that back farther, it became smaller. So how is this related to that degrees out there? And that's what we need to figure out. So here's what you need to make sure that you have in your notes and understand. An angle and its intercepted arc. That means the arc across from it. This is called an inscribed angle, ladies and gentlemen. See how the pointy part, the vertex, is on the circle? It's inscribed. It's still kind of inside the circle, but it's actually considered on the circle because it touches the circle itself. Now across from that inscribed angle is still an arc called the intercepted arc. It's still the arc across from it, except now it's not equal to it anymore because we've pulled it back. So what relationship do they have? Well, let's take a look at just one example here and we can probably figure it out. See, the arc across from this red angle, if I look across, see how that is half of the circle there? How many degrees would there be in half of a circle? 180. What if I pulled it back like that? What do you think the number of degrees are in that angle? You're probably looking at it thinking, that looks like about 90. And you would be correct, because the fact to know is that an intercepted arc, in this case, the measure of the inscribed angle equals half of the intercepted arc, so half of the arc across from it. So that means anytime I want to find an angle that's on the circle, like this inscribed one here, I'm going to be thinking about taking half of the arc across from it. So let's sort of sum this up in your little chart, okay? So we're talking about angles that are on the circle now, where we have the pointy part on the circle. So two chords would look something like this. This is a chord, and then we maybe would have another chord like that. So they make a pointy vertex on the circle itself. To figure this out, we would say the angle equals half of the arc across from it. Okay, so the angle equals half of the arc across from it. And it's a similar idea with the tangent and a chord here. If you want to go ahead and fill this one in. If we draw in a tangent line, and let's say a chord, and they have a pointy part that meets right there on that circle, we still look across, and that arc that's inside that angle, that's what's going to help us out. So the angle will equal half of the arc across from it. The intercepted arc is that arc across from that angle. So how can we work this out in some problems? That's what we're going to take a look to figure out here in just a minute. We have this beautiful circle. We need to find the indicated measure in circle C. So using what we already know, how can we figure out angle D itself and the measure from A to B on the curve or on that arc. So let's look at angle D. Angle D is right here. Angle D is an angle whose vertex is on the circle itself. It's an inscribed angle. So to figure that out, we would look at the arc across from it. I trace my two sides here of my angle, and the arc across from it is all the way from here to here. How many degrees is it on that arc that's across from it? It's 100. So how does that help me find angle D? Well, the angle is going to be half of that intercepted arc. So I already know the arc is 100, so all I do is take half of that, and the angle has to be 50 degrees. Well, how far is it, the measure of arc AB then? Well, let's go to our picture and see if we can mark that up. A to B, oh, I think that's supposed to be A to D. Sorry, A to D is here to here. How many degrees is it from A to D? Well, that's an arc, and if I look at the angle across from it, the angle across from it says 35. Well, I know that the arc is going to be, or the angle is half of the arc, so that means all I would do is double it to find that arc right there. So I would say 35 times 2 would make 70. So the measure from A to D, the arc now, here to here, I can still find that by looking at the angle across from it, but I need to remember that the angle is half of the arc itself. So there's this whole idea now of taking a look at the arcs across from it and using that to help us find those angles. So here's another picture that we should think about. And we want to know, what is the intercepted arc for angles J and K? So if I look at angle J here, that's this guy, and I trace out the sides and I go all the way across, the arc that is his intercepted arc would be from M to L. And if I do a similar thing for K, here's K up here, and I look at the arc across from him, it's also M to L. So what would we know about those two angles? Well, because they have the same arc, wouldn't those two angles be the same? Yeah, so they'd have to be the same size. So J and K have to be congruent angles. What about L and M? Angle L and M, similar idea here. Let's take angle L. Let's see, angle L right here. And now angle L could be, oh, sorry, I marked the wrong one. Angle L right here. If I look across from him, that's J to K is his arc. Okay. And now if I do the same thing for M right here, and I look across from him, same idea. So because they're across from the same length arc, that means they're going to be the same size angle. So picking out those arcs or those pieces of circles that are across from those angles, those intercepted arcs, going to be pretty important. So here's one big idea maybe to think about or get in your notes. If two inscribed angles intercept the same arc, then the angles have to be congruent to each other. That's just what we said. So one last picture here, and then we should be good to go. We're going to find measure of arc KN and then the measure of angle KMN. So finding the measure of the arc from K to N. That's this. We want to know how far it is from there to there. So let's go ahead and take a look at the angle that's across from him. If I trace those sides in, I notice that they meet here at this 52-degree angle, and we know that the angle is half of the arc. So that means this arc has to be 104 degrees, twice as much as 52. Now what about angle KMN? KMN is this angle right in here. Well, notice if I trace his sides out, that angle is also across from the same arc. So remember, we just said this was 104 degrees of the circle. So now if I want to go back and find that angle, the angle equals half of the arc. So I would say that the angle is also 52 degrees, just like angle L up there. So using this idea of looking across and finding those arcs is going to help us find angles that are on the circle, whose vertex is on the circle. Okay? So thank you very much for taking good notes, and I'll see you later.